Sí, it is off.
Okay.
Oh, wait. How is there a way to?
What would you like to do?
Just to remove the toolbar for the people in the room, but
But I'm not sure how to make
no,
it.
me neither.
Maybe we should start and show and start it again. I'm not sure.
Hide floating meeting controls.
Right. Maybe this. Try. Yeah.
Okay. Okay, good. Shall I start then? Okay, thank you very much, Guidre and colleagues, for the kind introduction and for the invitation to give this talk. I'm really honored to open this conference with a topic titled "Linked Data as a Cornerstone of Linguistic Data Science." My name is Jorge Gracia from University of Zaragoza. I will try to do something different. I didn't want to come here and show you like an academic talk with the recent advancements or experiments in our labs, etc. But trying to do something more informal, more high level, more opinionative, more something different. Let's see if it works. Let's see. I'll try to use this button. Okay, let's start. Do you recognize this map? What is it? I don't hear you.
Laws of rings.
Well, this is the map of the Middle Earth. Actually, it's there. When thinking on this presentation, I wanted to somehow picture in a map the topics I'm talking about, and it was really difficult until I found that an analogy with the Lord of the Rings would help a lot. I don't know if you are here fan of the Lord of the Rings. If you are, then you will enjoy it more. If not, there's no problem, because it is equally understandable. So what are we talking about? This is a map of the Middle Earth. We're talking about deep learning, big data. Well, it is not that I'm taking a lot of time for this, but these are topics that I will mention. I put this in the lens of humans, because in the third age of Lord of the Rings, humans are like the growing race. They are increasing in population, and it is said that the future of Middle Earth is in their hands. So this is what they are saying about deep learning right now. So these are in Gondor and Rohan. What else do we have in the map? Well, of course, because of obvious reasons, data mining, I reserve it to the dwarves near Moria. And symbolic artificial intelligence. So this is near Lorien. Lorien is a kingdom inhabited by elves. Elves in the third age is a very powerful race with a very interesting history, they are magicians, they are very powerful, but they are declining. It's a declining race. But still they are needed to win the war. So this is what I put elves with symbolic artificial intelligence. Symbolic meaning knowledge graphs, explicit knowledge representation, rules, etc. Things that are less fancy than deep learning at this moment. Close to the Shire, where hobbits live, I put linguistic link data. Because hobbits in the Shire are like a small community, very quiet, very well organized. They have things clear. They like their way of living, and they don't want to get in troubles. But still, they are needed for the success of this story. They are needed for the highest feats. Okay. So, and what else? And what is the enemy? The enemy is there in Mordor. It's a messy data. These are orcs. Let's say that these emerging deep learning techniques, big data techniques, etc., have stimulated a lot the data science field. Data science, some people say this is just a rebranding, a fancy name for statistics. But well, now it is. There's no doubt that there's an emergence of this topic, and it is important. But today we are also talking about linguistic data science. In the map, I would put linguistic data science more to the north, closer to linguistic link data and closer to symbolic artificial intelligence. So explicit mechanisms to explicitly represent knowledge. So, well, this is in a slide, in an analogy, topics that we were talking about today. Look, this is how Mordor looks like. It's hordes of data, very heterogeneous, connected, well-connected, well-formed, curated, non-curated, monolingual, multilingual, etc. So it's really growing and a bit messy, and we want to put some order on it to take advantage of it and infer most of the knowledge and most of the useful information we can out of it. In numbers, this is a graph of how the data consumed worldwide has been increasing. If you take a closer look, you can see that mostly every 3 years, the data is doubled. Compare this year, 2022, 97 zettabytes. I cannot even imagine what a zettabyte is. Compared with the 6 of 10 years ago. So it's growing increasingly and with a capacity which is possibly out of our minds to really grasp. So the situation is that we have more and more data. We have more and more unstructured data as well. What about, I want to give a word on deep learning, in particular, large language models, because jointly with big data, it's one of the trending topics. If you want to publish in ACL or similar conferences, it's better that you have something on language models or deep learning in the abstract. The idea of this deep learning in general comes from the old endeavor of trying to mimic or replicate our behavior, how our brain works. It started in the 40s with McCulloch and Pitts, who modeled the neuron for the first time. After that, in the 60s, in the 50s and the 60s, they combined neurons and architectures based on artificial neural networks emerged. like the perceptron, multi-layer perceptron in the 80s, the backwards propagation algorithm, etc. That, yeah, it gave floor to this technique of artificial neural networks to evolve and to emerge and to solve a lot of problems. But that was the basis for deep learning, because possibly at that time, at the 80s, 90s, the technology was not ready to exploit its full to be exploited at its full potential. And it's just recently that the computers, the capacity of the computers, the memory of the computers, etc., allows us to really implement huge neural networks with a huge amount of parameters, of nodes, of neurons, connections, etc. And this is what this could be a typical scheme of a neural network, having a lot of neurons, a lot of parameters, so classified as deep learning. The idea with this is to support machine learning techniques, as for instance, this in the example, you have a picture as input, and then you have to classify it in between hobbit or orc. The system has been trained with a lot of pictures of hobbits and of orcs, and then you enter input and scene picture, and then you have to decide. The system has to decide. But yeah, this is about deep learning in general. Now, these deep learning techniques are extensively used for language models, as you know. What is a language model? It's simply a predictive model. You have a text, and then you predict what comes later. The student was late for what it will come later. So school, red car, archetypes. The system has to weight any possibility, and possibly the highest rate or the most probable is school. Student was late for school. So language models, they have been language models for a long time ago, based on basically on statistical analysis. But now it was because of this paper, attention is all you need in 2017. This paper changed a lot of things, as you know. Well, this is not the transformers we're talking about, is this. So this is they propose a new architecture of artificial neural network based on the attention mechanism. The attention mechanism tried to capture the context of a word and somehow being able to interpret at a certain extent the language, thanks for the analysis of the context and the analysis of a large amount of language, of text, sorry. So one year, yeah, okay. One of the cool things of transformers is that it can be easily fine-tuned for many tasks. It is trained for text prediction, as I said, but it can be fine-tuned for doing any NLP task you can think about, like sentiment analysis, text classification, machine translation, etc., etc. So another inflection point was this BERT model from Google, 1 year later, that implemented this architecture in its own way. And yeah, it beat a lot of benchmarks of NLP, advancing the state of the art really a lot. The GLUE benchmark, I think it improved around an 80%, etc. So it proves that really this architecture worked pretty well. This is just an example of how this can be used for fine-tuning. You have the pre-trained model, and then you add a layer, here a classifier, to specialize it in a certain task. For instance, classify spam classifier. So with little effort, unless it's less effort than starting a machine learning system from scratch, you have a system that classifies, and it works pretty well. So the next big step was given by OpenAI when they presented GPT-3 in 2020. I will not introduce more language models because, well, you know, they are even bigger models now, and they are permanently evolving. But the GPT-3 was also a landmark because the amount of parameters that they use was increased like in several orders of magnitude, and the performance increased as well. OpenAI was, GPT-3 is able to generate text very fluent, grammatically correct, very difficult to coherent between paragraphs. So very difficult to distinguish from human-made writing. One of the coolest things of GPT-3 and the very large language models is zero-shot learning, meaning that without this layer of fine-tuning that I showed before, it's able to do stuff, not having been trained for that. For instance, it can add numbers. So using the predictive capabilities of this model, you can just put a zoom and it will give you the result. But many more things like typo correction or even translation. Well, this is working because apparently in the training process of GPT-3, it has seen texts in French, so you can translate into French as well. So the cool thing is that you are not training specifically this for adding typo correction or translation. It's something inherent to the model because it has somehow learned the language. Yesterday in the plane, I read an article, I didn't have time to include this information here, that the largest models, not GPT-3, but even largest models, are able to play chess. They have not been programmed at all to play chess, but they have read books about chess. And they are able to do legal moves of chess, and they are able to interact in a chess match. This is awesome, really awesome. That's an example also of question answering with GPT-3. I really like this. For instance, the first example, how many legs does a frog have? A frog has 4 legs, it says. It means that it knows it's aware of factual knowledge. The second question is, there are animals with 3 legs, and it says no. And it shows that it's doing a sort of inference. It's not only factual knowledge, but some minimal logical reasoning. And the final is my favorite one. Why don't animals have 3 legs? It answers, animals don't have 3 legs because they would fall over. So it's able to somehow apply some common sense reasoning, not only factual knowledge. But this is awesome. This is wonderful. Why do we need anything else than language models? Look, we have to use language models with caution because they are not perfect. For instance, well, I like this joke a lot. Yeah, here's this lady in a robotic cafeteria, and she says, "Espresso, but I ordered a cappuccino." The robot says, "Don't worry, the cosine distance between them is so small that they are almost the same thing." So I don't know if I mentioned it, but internally, language models use vector-based representations of words. These are contextual vectors, contextual embeddings, differently with other static embeddings method as word2vec. But the joke is just to raise awareness that we cannot take a direct result from a language language model as good without any filtering. Okay, because it has some limitations. For instance, first of all, I say that for fine-tuning, it's very useful and it saves you a lot of effort and computational power. But if you want to build your own transformer, it's very expensive to build it and train it from scratch. This is why the largest ones are on the largest companies' hands, like OpenAI or Google or Facebook, etc. They have no memory. And so from one computation to another, they can forget things. This is an easy fix. I mean, they have no memory because the standard way they have not implemented it, but they do no complex calculations. I show how it can add numbers. So over maybe 2, 3, 4 digits, it doesn't work. This is not important as well, on my view. But the most important thing is that the results are not explainable. So it gives you an answer, but it does not explain you why I reached that conclusion. It does no knowledge of current affairs. So it has been trained at large with a lot of information, but something that is happening right now, they are not aware of. For instance, if you ask who is the president of the United States to GPT-3, it will say Donald Trump. And the answers are not trustable because of the previous reasons. And they are growing in multilingual capabilities a lot. It's impressive. Now they are multilingual and very good language models, but still capabilities are limited for a good number of languages. Okay, so language models are wonderful, but it has some limited capabilities. Well, that is almost true. I read somewhere that GPT-3 is rubbish because it does not add well more than 3 digits. So what? This is proposed as a step towards a general artificial intelligence, and it is not able to add more than 3 digits. I would say this is not a fair argument. And I would say also, hey man, calculator was invented like centuries ago. Use it if you need to calculate more than 3 digits. So there's a sort of controversy. There are people very in favor of language models and people very against them. I prefer like the middle term. An example of this is Hinton, one of the fathers of deep learning, saying, for instance, deep learning is going to be able to do everything. Isn't it ambitious? But it says that in this interview in the 2020. On the contrary, there are people, I wouldn't say against language models, but questioning that it is a step towards artificial general intelligence, like Gary Marcus, who wrote an interesting paper, Deep Learning is Hitting a Wall. Well, I don't know if it's a paper or it's a blog entry. It's a blog entry. Okay, so there are like two sides confronted. And but I prefer to be like in the middle. And there's a growing feeling in the community that the next steps will come from hybrid solutions. You know, on the one hand, there's symbolic techniques, traditional artificial intelligence, symbolic-based artificial intelligence, rules, knowledge graphs, logic that has worked well for many tasks, for many years. On the other hand, non-symbolic techniques that works pretty well for pattern recognition, things that are not easily programmable with conditions, with ifs, fors, etc. For instance, to recognize a face or classify an image or speech for speech recognition, etc. So these are non-symbolic techniques based on statistics, neural networks, etc. So as I said, there's a growing feeling that things will work better in a combined way, in a hybrid way. Just for reference, I don't enter into any detail. I found these two systems, Jupyter X, and this quite alpha GPT-3 and Python interpreter, that are steps towards adding layers on top of language models with more traditional stuff, either relational databases, rules, knowledge graphs, etc. Okay, so I have talked a little about big data, a lot more about deep learning and language models, but coming back to the title of this talk. What is the role of linguistic data science in this challenging context in which things are evolving so rapidly? I don't know if you have the same feeling as me, that if you haven't read a paper from 1 month ago, you are out of date already, because things are evolving so rapidly that it is, well, for me, it's difficult to follow. But on the first place, what is linguistic data science? In the first place, let's try to define it. Well, an obvious first step is to define data science. Coming from this diagram from Drew Conway, data science is like in the intersection between computer science, math and statistics, and domain knowledge. I added the data into the diagram because the data of data science is typically there in domain knowledge. Medicine, well, it's data about medicine, for instance. So the idea is to apply statistical techniques in order to analyze data and to infer new knowledge out of it, and to, well, analyze the structure of data and make reasonable predictions, etc. I like this quote by Hadley Wigman, which is a famous R developer. Fundamentally learning about the world through data is really, really cool. I would paraphrase it saying, fundamentally learning about language through linguistic data is really, really cool. That I think this possibly is closer to your way of thinking as mine. So if we just extend this diagram and put linguistic on it, we have like the context, the landscape of linguistic linked data. Sorry, linguistic data science. We haven't reached the linguistic linked data yet. We are not in the share yet. Okay. More formally, what is linguistic data science? I did a web search to try to see definitions of linguistic data science. You know, data science is a mature field. There's a lot of definitions of it, but linguistic data science, not. First thing I wanted to try is to ask DALI. Do you know DALI? DALI is well, a large deep learning model that pictures. It has been trained with captions of images. So you can insert a caption and then it pictures you whatever you want. For instance, I want a picture of Ronald Reagan dressed like a Spiderman, something like that. And it will work pretty well. It's scary as well how it works. So I wanted to do a try and ask DALI, picture linguistic data science for me. And it gave this. That possibly doesn't mean anything, but it's very nice. It's very nice. Typically, when it prints text, it's not understandable. I don't know if you understand anything, but I like it. It's beautiful, isn't it? So according to DALI, this is linguistic data science. I made a Google search and I found several schools, several universities where they are giving master classes in topics around this. Several definitions were not, well, they were not very good. There were no distinction with NLP, for instance. But this one from Doshisha University, this one I liked it. It says methodology of data analysis and computational science is why in the center of this previous diagram, to solve theoretical and empirical problems difficult to solve with other ways. And finally, discovery and theorization of new linguistic facts through processing a large amount of linguistic data. So this definition is more satisfactory than others that I found out there. And this could be easily mapped in the definition that we at Nexus Linguarum gave. as a subfield of data science that provide the formal basis to analysis, representation, etc., of linguistic data for language analysis and language applications. This was in the previous definition, was said about theoretical and practical approaches. So yeah, that's the notion of linguistic data science, basically. The key point is, well, the definition maybe it's not so informative. Let's analyze it a little more. The key point is that data science in general still relies a lot on the statistical dimension, on the analysis of large amounts of data. But could deep learning alone answer a question like this one? Which words in corpus X have a Greek etymology and have translations into Portuguese coming from a dictionary Y? Well, this is out of the capabilities of language models alone. In combination with other stuff, I wouldn't say no. And this is where linguistic data science can help by introducing other type of techniques. It needs, of course, implicit representations of linguistic features. So it is not that linguistic data science forgets about statistics, etc. It can use distributional semantics, embeddings, etc., but complemented with explicit representation of linguistic data. To that end, we will need words, grammars, senses, concepts, ontologies, any mechanisms to formally, explicitly represent language features. So I like to see this as a step in the direction of this convergence I mentioned before of symbolic and non-symbolic techniques. This could be easily placed into that direction. And the key point is that we are moving from data science to linguistic data science. We're moving from data to linguistic data. Well, that is obvious. From plain text to linguistic features. As an example, data science would process magicus only as a label. Magicus is the Latin word for magic. This example comes from the Lila project. But if you want explicitly represent linguistic features, you can actually exploit a lot of more information, like a part of a speech, the label, the written representation, the grammar category, other conceptual relations, inflections, etc., etc. So that's the movement we have to do from data science to linguistic data science to really exploit this very rich information, also with the help of statistical and pattern-based recognition methods, etc., but with the focus put on this explicit representation of linguistic data. Again, coming back again to the title, well, why linked data can play a role here? Because linked data can carry out representation of linguistic knowledge, explicit linguistic knowledge at its highest level. Does it sound ambitious? Maybe a little, but it is true, I would say. But what is linguistic data in the first place? Many of you already know it. For those who don't, I will very briefly introduce what is linked data in 3-4 slides. It's challenging because I always tend to expand it myself with this. So the core thing in linked data is the RDF, the triple mechanism, when you describe facts or describe the semantics of things in a machine readable way as triple: subject, predicate, object. For instance, Frodo Baggins' home place is the Shire. This is Frodo. This is the Shire. So in linked data, you need to define the the subject, the object, and the predicate to link both things. Any ingredient in this representation uses any individual, any property, any subject, predicate, object. Well, object not always, but all the rest use URIs, uniform resource identifiers, which is like a generalization of URLs, the address, the web address you put in a web browser when you are finding something. So this URI allows you to identify at the web scale the entities, the ingredients you are playing with. And I can expand, thanks to this very straightforward modeling technique, I can expand with more information. The Shire has this picture. Baggins, Frodo is a hobbit. He's also a fictional character, etc. Frodo is an individual, a particular member of a certain class. In this class, the class it belongs to is fictional character, and properties link two different individuals or an individual with a certain value. So properties individual classes are like the main ingredients of ontologies that are defined in OWL in the context of linked data. With these mechanisms, you can represent conceptual, you can declare conceptual information about things, for instance, about fictional character here, in a very rich way. And also linked data is useful to connect things, to connect data sets. Here, imagine you have, well, this is a real example. DBpedia, you have Tolkien, the URI of Tolkien, because Tolkien is defined with a URI in DBpedia. So you can state things about this. It is not, I mean, you can, with URI, you can point to, you can identify general concepts, abstract concepts, informational stuff like images, audio files, etc. And in this case, we are modeling someone coming from the real world, Tolkien, and we are stating information like birthplace, country, etc. But there's the Spanish National Library that has a lot of books about Tolkien and with Tolkien as author. So it has also Tolkien as a URI, and in order to state that both things are the same, you can use an OWL clause, same as, and then you can go from one place to another. In the in the National Library portal, since they know that this URI is the same as the one in DBpedia, they can additionally get facts about Tolkien, birthplace, country, this picture, and enrich its own information, its own portal with it. Okay, so I talk about linked data in general, but the same mechanism can be applied to linguistic information. Imagine you want to model a kingdom, not in the geopolitical concept, but as a word, in particular in the Quenya language, which is a language spoken by elves. So you can say, well, this URI, exemplary URI, Arani. You can state that this is a lexical entry. The part of the speech is noun, and the language is Quenya. Actually, I discovered that there's an ISO code for Quenya language. Interesting. So you can state linguistic information with this mechanism. And then you can do the same things, combine information, query information, traverse information from one source to another, etc. Thanks to the linked data paradigm. So yeah, that's perfect. Everybody should use it. Really? Well, people sometimes are not ready for it or don't want it, as Isildur in this example. And then this leads to a situation that sometimes, not always, but sometimes is not desirable, which is having language resources as data silos. So isolated among themselves, disconnected, using different accessing APIs, etc. in heterogeneous format, non-standard formats, etc., etc. So in that scenario, the linked data mechanisms could allow things like this. Here, a word, red, network in Spanish, is represented in several data sets, each of them having different information, like etymology, part of the speech, images, etc. And if we represent them following the linked data standards and common models, like Lemon Ontolex, then we can reach a situation in which the information is connected, is interoperable, and we have a single entry point to access in a single query many of these things. Well, I already mentioned this. And this linked data stuff leads to this cloud of linked data. Part of it is linguistic information, the bubbles in green. Every bubble is like a data set. Okay, so the thing is that linked data is an emerging technology. There's a lot of progress on it. It's very useful for linguistics. Several projects have demonstrated it. For instance, the Lila project about Latin. There are families of dictionaries like Lexicala that has been converted into linked data. Just to mention a couple of examples. But there are challenges. In this paper under review, developed in the context of Nexus Linguarum, Working Group 3, led by Dagmar Groman, we reflected on the challenges of linked data, because one does not simply publish linked data. It's not so easy. One does not simply go to Mordor. One does not simply publish linked data. It needs some familiarity, some learning curve, etc. So I will not mention all the challenges. I will just summarize it in three, four main ones. Entry barriers to the technology. Possibly people in the room or even at home have experienced this. It's a very cool technology with a lot of potential, but it's not easy at the beginning. It has a steep learning curve. You possibly need technical support. So in order to mitigate this, in Nexus Linguarum, we are trying to invest in education. On the one hand, organizing datathons. On the other hand, we foresee to prepare a MOOC and also a common curriculum for linguistic data science, etc. And we need also more user-friendly tools. Sustainability, because, well, you can transform your data into linked data, as we showed in the previous pictures, but what to do with this data? You can, if you store it in your hard drive, we have gained nothing. So we need sustainable solutions, and we need to, solutions to have places where we can upload and exploit the linguistic data, linked data out of there. There are two possibilities: either to put the burden on the provider to set up all the infrastructure, or on the consumer. It simply downloads the data, but it has to set up the triple store, etc., locally. So intermediate solutions will be most welcome. Also, we analyzed the coverage of representation models. We saw that some linguistic levels are very well covered, like semantics, lexica, etc., but all others not, like phonetics, pragmatics. So researchers, people interested in such kind of information, possibly will have more issues trying to represent the data as linked data. So maybe the community should work on that directions as well. Then cross-lingual linking, since linked data is about linking, cross-lingual linking is always a challenge. There's a lot on cross-lingual linking, but a lot of more algorithms, of more systems need to be developed in that direction as well. So we need to address these challenges to avoid situations like this, in which Bilbo is still not convinced, still using its proprietary formats, not wanting to to link to anyone else outside the world. Okay. Just final minute to some final thoughts. I think that we could, as a community, move towards trying to this intersection I mentioned before between symbolic and non-symbolic, etc. I brought here two hypotheses. Deep learning can take advantage of symbolic approaches, and hypothesis 2, symbolic approaches can take advantage of deep learning. If we refine this in sub-hypothesis, we can substitute symbolic by linguistic linked data. And I'm convinced that linguistic linked data can take advantage of deep learning and the other way around. Actually, this hypothesis 2.1 is something we are actively working on in our labs and also in the context of Nexus Linguarum Working Group 3. And that's it. There's a final slide for a final message, which is I tried to present what is happening now, which is data is exploding, data is growing, data is messy as well. And statistical approaches, deep learning approaches are very successful, but possibly not enough, and can take advantage of explicit representation means of linguistic content, for instance, the one provided by linked data. And moving in that direction, we will be moving also in this expected intersection to get the best of these two worlds, symbolic and non-symbolic. And yeah, I think this is the linguistic linked data, even despite the challenges I showed before, it's still quite advanced and it is useful, and it can be used right now. And yeah, possibly we have to work together to overcome these limitations and their challenges. And with this, thank you very much for your attention. It's time for any questions.
Thank you for your wonderful speech. Really, I enjoyed it. I like talking and a lot of drinks. As we started like a few minutes late, so I need to allow maybe just 1 or 2 questions, because we need to make them group photo, and then I will need to give some kind of directions. So any questions from the audience here or online? Let me double check the chat. Okay. Mm-hmm.
Yes, thank you very much. I also enjoyed the presentation style, the way you presenting colleagues. One thing is the human brain always explain the person in your fashion. And I think that this should also look at the way we communicate between human, the way we ingest knowledge. So we need this word we need something which is not full of communicate. So we ingest translucent. But maybe the brain is, I guess it's working, it's learning. But where does the symbolic part come to everyday life? I think it's the communication and the transmission of information. And I think this is something that should also be addressed at this data. Why do we need symbolic? I think it's just because of communication. We cannot communicate directly from better to better.
Yeah, I think that's a very good point. We need, I think that finally this communication between these two worlds could happen in a similar way as humans do, as you said as well. Maybe we think, I don't know, maybe we think with vectors and patterns, but at some point we need to consult, for instance, external knowledge, and we need to formalize knowledge. We open books and read, we go to Wikipedia, etc. And also this common information, the one that are in dictionaries, as, for instance, or in grammar books, are like the grounding of the common communication. So I think that's that's a good point in the sense that this joint two worlds could take place or could happen or be successful in this communication layer, as you point out. So yeah, I fully agree.